Now it is. Okay? So best behavior. Alright, so last night we talked about converting, right? We talked about how rational exponents, and what do I mean by rational exponents? I said it about 15 times. Rational means fractional, right? So when I talk about rational exponents, I'm talking about exponents that are fractions. So we talked about how we can always take rational exponents and we can convert those to what?
Fraction.
No. Starts with an R though.
Right.
To radicals. And that was the connection we made there. Rational exponents can always be rewritten as radicals. And vice versa, right? We can take radicals and rewrite those as rational exponents. So the key that we discussed, whether I'm going from rational exponents to radicals or radicals to rational exponents, the key is the what? The key is the denominator of that fractional exponent, right? The denominator is the key, yeah. It's the root, right? The root is the denominator. The denominator is the root. And if you get that down, if your focus is on the denominator becoming the root or the root becoming the denominator, in my opinion, everything else just kind of falls into place, right? Everything just kind of falls into place. So let's go ahead and discuss a couple of these that you may have struggled with. So looking at your homework assignments, which was 1 through 10, what problems would you like me to go over?
4.
Number 4, 5, 4 and 5.
Proof.
9.
Mr. Postula.
Uh-huh.
Proof that it's done. And text to my dad because he said that he texted me and said that my homework was on the table because I forgot.
It doesn't matter. Remember, I'm not taking it until tomorrow.
Proof that I did it. I just don't have it. So I'm just finishing it today on the paper.
Alright, so let's look at 4. And I should just make you aware, Allie, you're being recorded. This class. Diana, I want to slap you.
Whoa.
Whoa, y'all hear that? Whoa.
Yeah, we got proof now.
That is.
I'm not afraid.
Dude, don't
Okay.
cut that out.
No, I'm not cutting anything out. I'm not afraid. What are they gonna do?
You know what they'll do to you in jail?
I'll show that to
I'm just threatening it. I'm not actually.
You're still threatening it.
No, she lies about it. So, we got.
I guess
You
actually,
actually say it.
you probably could get me in trouble.
Did you just slap me?
Oh my goodness. Okay, anyways. I'm gonna delete that recording. Okay, so somebody asked about number 4. We're taking a rational exponent. How do I know this is a rational exponent? It's got to be clear to you. How do you know it's a rational exponent? The exponent's a fraction, right? Okay, so we're rewriting it as a what? As a radical. What's the key? The denominator. The denominator is my root. So what's my denominator?
4.
So this is the 4th root of. Okay? And what's underneath that radical? 256x. And what exponent is it raised to? The first. So do I need to worry about putting in parentheses or anything like that? No. Okay? Now here's why these are a little bit harder. Is this problem done?
No.
Why not?
Simplify.
We're going to try to simplify. We don't know if it'll simplify yet, do we? So we check. Is 256 a perfect fourth? Y'all remember how to check that in your calculator? In your home screen, type in 4 math 5. 4 math 5, and it'll be 4th root of, and then just plug 256 in there. It comes out all the way, huh? So the number comes all the way out as a 4. But what about that x? Why? How do you know it stays in? Because its exponent is 1, and 4 won't go into 1. So x can't escape. So it's 4 times the 4th root of x. That's all the way simplified in radical form. 4 times the fourth root of x. Okay? So that's that problem. It's not too hard, right? Number 5 was also asked about. So let's look at number 5. Did I move too fast away from that? Okay, very similar, right, to that last problem. I know it's a rational exponent because the exponent is it's a fraction. So we're going to rewrite this as a radical. The denominator is my root. What's my denominator? So this is the square root of. This time, what's underneath that radical? Mn. But it's raised this time to what power? So it all needs to be raised to the 7th power, correct? All needs to be raised to 7th power. That means that m needs to be raised to 7th power and n needs to be raised to 7th power. The only reason I do that is because will 2 go into 7? How many times? So m gets to escape 3 times. But 3 times 2 is 6, right? How many were there in there? So how many are remaining in there? So there's 1 m still left in there. And won't the exact same thing work with the n? 2 goes into 7 3 times, so n gets to escape 3 times with 1 n left over. So my answer is m cubed n cubed times the square root of mn. Okay? And that's it. That's all you really have to do here. All right? Any more you'd like me to go over? Number 9? Okay, let's look at number 9, and then we'll do today's homework. This one's going the exact opposite direction. So what's still my key, guys? The root is my denominator. So what's my root here? So I'm going to go ahead and put that 3 in the denominator's position. That way you can let everything else fall where it needs to fall. Okay? For example, what's going to be the base? What is the value that's inside the radical? 2w. And does it have an exponent? So all of this 2w, so I need to emphasize that with parentheses, all of that 2w is in that radical. So all of it is raised to the 5 thirds. 5 thirds. Remember, 5 is that exponent, so it has to be the numerator, and 3 is the root, it has to be the denominator. So 2w in parentheses raised to 5 thirds. Yes, sir?
So what's the parentheses for?
Because you have
outer ones.
These.
Yeah.
It's just another way of writing the same thing. Sometimes, so they don't have to put, let me show you this. It's a good question, actually. So they don't have to put parentheses inside like that. They just take the whole thing and put parentheses around the whole thing. These are identical in value. Okay, it's just 2 different ways of writing the same thing. And here's why. Okay, let me show you why. Because this is a good question to ask because a lot of people don't understand why this is the case. Technically, what we have here, the way it's written, we have 2w raised to the 1/3, and that's raised to the 5th power. Well, if you think about it, when you do a power to a power, you just multiply. So 1/3 times 5 is 2w to the 5 thirds power. So it's the same thing as if that exponent were inside. So anyways, whenever you see that exponent out there, you know it's just going to be the numerator of your fractional exponent. Okay? All right. So there you have it. Okay? Now, there's one other thing you could have done with this problem that I wouldn't have done, but somebody did ask if it was the same in first period. They said, could you do 2 to the 5 thirds, w to the 5 thirds? What do you think my response was? Absolutely. Okay, all you're doing is you're just taking both of those terms inside that parenthesis and you're raising both to the 5 thirds power, which is absolutely fine. I just think that the first one looks a little more appealing, and it just doesn't really help me to do it. So I know, okay? So anyways, that's how you do these. Hopefully You're going to be able to apply these today because we're going to continue to do this, obviously, but with a little different catch to it. So, can y'all handle 6 problems for homework additionally tonight? Does that sound fair? Okay, because after we're done with what we're doing, we're going to have 6 problems. So, I need you to stay focused because we're going to look at 4 different concepts basically. Okay, 4 different concepts. Here's the first one. The first one is, do you remember the rule for this?
What do you have to like add the x?
Exactly. When you're multiplying x to the 5th times x to the 3rd, when those bases are the same, you're going to add your exponents. So that's going to be 5 plus 3, x to the 8th. Okay? Now, does this right here follow the same rule? X to the 5th raised to the 3rd? Does that follow the same rule? Are you going to add those? 5 plus 3 is 8?
No.
You multiply. This is a power to a power. When you have x to the 5th, so one base, but you have 2 exponents, that's a power to a power, you multiply your exponents. So the base stays x, but 5 times 3 is 15. Right? And then another one is division. If I have x to the 5th divided by x to the 3rd, what do you do when you're dividing? You subtract. So 5 minus 3 is 2. So that becomes x squared. So those are the 3, basically, 3 operations that we're going to talk about when we're dealing with rational exponents. The biggest difference, the reason why people who handle this just fine, the reason they may struggle with it a little bit when we get to a section like today is our exponents are fractions. And sometimes that causes us issues. 3 plus 5 is real easy. 5 times 3 is real easy. But 1/5 times 2/3, that's a little harder for people sometimes. So a couple things to remember. How do you do fractions in your calculator? Where do you go to do fractions? Alpha, y equals. Alpha, y equals. And it's number 1 up there. That's how you deal with fractions. So I would definitely get used to those buttons. They'll help you out with these fractions quite a bit. I told you there are 4 concepts. We'll get to that 4th one here at the very end. But we're using these same rules, but we're dealing with fractional or rational exponents. Now, there is another catch. I want you to look down here, and we're going to do several of these, but I want you to go all the way down before we even get started to number 29. Are those rational exponents? No, they're radicals, right? Those are radicals. Do those same rules apply to radicals? No. So does that mean I can't simplify this? No, of course I can. How though? What do we know about radicals? We can always change them to rational exponents. And once I've changed them to rational exponents, guess what I get to do? These different operations. And then I can just change them right back. So those are going to have a couple steps. So we'll get to those in a second. Let's do a few of these, and hopefully you guys will be able to do it. So number 1 tells you to first rewrite all radicals in exponential form. So if it's not in exponential form already, write it in exponential form. Okay, second, use these exponent rules that we've talked about to simplify the expression. And then 3, write your answer as a radical in simplest form. So let's look at number 1. What do we have here? X to the 1/3 times x to the 4/3. Which rule is that applying? When your bases are the same and you're multiplying, what do you do with your exponents? Nobody? Is this because you're being recorded? Or you guys just don't know?
Can you repeat what you said?
Yeah, I'll repeat it. What rule are we using here? When you're multiplying and your bases are the same, what do you do with your exponents? You add them, right? So you're going to add those. Whether you do it in your head or whether you can do it with your calculator, you need to add 1/3 and 4/3.
What did you have to like? What did you use 4 plus 1?
Yep. 4 plus 1 is 5. So it'd be 5/3, right? 5/3. So this is x to the 5/3.
What if we like put it into mixed numbers?
We're not going to do mixed numbers for one main reason. Remember, we're having to now rewrite those as radicals. And if they're in mixed number form, you can't rewrite them as a radical. They need to be improper in order to rewrite them as a radical. You need to have a numerator and a denominator. Okay? So here we go. Now that we've got these together, we can rewrite it as a radical. Remember, the denominator is the root. What's my denominator here? 3. So it's the cube root of x to the 5th. The cube root of x to the 5th. Now, is this one all the way simplified? Hopefully you guys all recognize it's not. Why? Because 3 goes into 5. How many times? So x gets to escape 1 time. What is 1 times 3? So 3 of those got to come out. How many were there? There were 5. So how many remain inside? So my answer is x times the cube root of x squared. Now that radical is all the way simplified. Done. Okay? What think you? Good? Like that old English? What think you?
I don't like that.
What's
Hold
that?
on.
What do you
Hold
think?
on. Hold on.
What do you
Sorry.
think? What think you?
I don't think you did.
What think you? What do you think? What think you? Never mind, just forget it. Moving on. Okay, let's use another of our rules. What rule are we using in this particular case? Subtraction, right? Because we're dividing. Our bases are the same, so we're subtracting. So just write your base once, m, and then subtract your exponents. What's 5 halves minus 7/4? 3/4? Everybody get that? Again, alpha, y equals, number 1. Use that to take 5 halves and subtract 7/4. Now, some of you guys, maybe you can say, I know my denominator needs to both be 4s, so one of them already is, so I need to change 5 halves to 10/4, and then 10/4 minus 7/4 is 3/4. Maybe you do that. Maybe you process that in your brain. If not, alpha, y equal, number 1. 5 halves minus alpha, y equal, number 1. 7/4 equals, done. Okay? It gives you m to the 3/4. Okay? I'm not asking you guys to relearn how to deal with fractions. You guys have you have alpha, y equal for a reason, to help you out with that, okay? I would love it if you knew how to do fractions, but it's been a bit probably. So, now let's rewrite that as a radical. Remember the deal? The denominator is my root. What's my denominator? What's my root?
4.
4.
Sorry.
The 4th root of. You gotta say the denominator is the root. What's the denominator? 4. What's the root? 3. I don't care. You.
You know what they're gonna think of you now?
It's your birthday, and I'll let you cry when I punch you.
What?
Is that how the song goes? It's my birthday, and I'll cry if I want to. So it's your birthday, and after I punch you, you can cry if you want to. Yeah, I know. I'm a terrible person. Alright, so it's the 4th root of m cubed. Now, is this one done? Yeah, because will 4 go into 3? No, so since 4 won't go into 3, none of those m's get to escape. They're all trapped, and that's the answer. Okay, easy does it. Let's go over here to number 22. This is the first one that we've seen that uses this property. What's this property tell us? We have a power raised to a power. So when I have a power to a power, what technique do we use? We multiply. So our base is still just A, but we multiply. 1/3 times 5/2. What do we get? 5/6. 5/6. So I've got it all together. Now let's rewrite it as a radical. The denominator is the root. What's my denominator? Diana, what's my root? 6. 6th root of what? A to the 5th. Will 6 go into 5?
No.
Done. I can't do any more. That's it. Okay? Alright, is that like a partial hand raise? Like you're thinking about hand raising?
No,
Okay. Just making sure. I thought it was like, I'm thinking about doing it. I just don't know if I'm going to do it. Okay. Alright, let's go down here to number 24. 24. Is everybody here with me? Okay, for number 24, I know that you've got a couple things inside those parentheses, right? Everything in those parentheses needs to be raised to a power, does it not? Alright, so there's a couple ways about this. You could go ahead and raise everything, or you could go ahead and write it inside a radical. That's probably what I would do. Okay, look. The root is your what? Your denominator of your fractional exponent. What is that? So it's the cube root of, what goes underneath the radical? 8x squared, right? And what should it be raised to? What power should it be raised to? The second power. Why? Because that numerator, it's 2/3, right? You could have done that, okay? Let me show you the other way you could have done it. I want to show you both ways. I'm going to do one in red and one in blue. Here's the other way you could have done it. You could have taken 8 and raised it to the 2/3 power. Whoops, sorry. Then you could have taken x squared and raised it to the 2/3 power. Don't you multiply? 2 times 2/3 is 4/3. Okay? Which one do you want me to do first, red or blue? Okay, for the blue, here's my next step. What is 8 squared? And what's x squared squared? X to the 4th. Y'all follow me so far? Now, once we finish that point, we say, all right, is 64 a perfect cube? Check it. Remember how to find cube roots? Math 4. And then type in 64, because you probably don't have your list with you. It is, isn't it? So the cube root of 64 becomes a what? It becomes a whole number 4. It comes all the way out. Right? Now, what about that 3? Will it go into 4?
Yes.
So, since it goes into 4, look, right here. Since that 3 goes into 4, x gets to escape how many times? Once. But 1 times 3 is 3. How many x's were there?
4.
So inside this cube root, you still have one more x. So all the way simplified, you have 4x times the cube root of x. Going in that direction, doing it that order. For this one, number 24 in red, the way I did it, I would say, well, the denominators for both those are cube roots. Right? That is the 8 squared underneath, and that's x to the 4th underneath. And then all of a sudden, don't you see where we're at? We're still at the exact same place, 64 x to the 4th. So, either way, you could have done this either way. See, look, at this point, I'm right to here. Here it took me 2 steps. Here it only took me 1 step. So, obviously, that's the one I prefer. So, I like the blue, okay? But they're the same. They give me the same answer. Just one extra step in the red. Okay? Questions about that? Okay. What I want to do now is I want to skip 25, which we're going to come back to, and I want to go down here to number 29. We're going to come back and do 25 and 26 real quick. They'll be so fast and easy. So 29. Can I go ahead and just start throwing in my properties that we've just been dealing with on number 29? No, because they're written as what? Radicals. And those properties don't work with radicals. They work with rational exponents and exponents. So we got to first do what with these radicals? We got to rewrite them as fractional exponents, right? Rational exponents. So here we go. Let's start with that first one. It says the cube root of b. The cube root of b. So, guys, the root becomes my what? The root becomes my denominator, right? So cube root of b is going to have a denominator of 3.
But wouldn't it be 2?
What would what be 2?
The numerator?
Nuh-uh.
Why not?
Because what is v raised to in this particular one?
1.
It's understood to be a 1. Okay? So it's v to the 1/3. Now, Diana, you might be looking over at the next part. What's the root of that second one? It's square root, right? It's a 2. So my denominator in that second one is a 2. So that one's v to the 1/2. Y'all see how we took these two radicals, we rewrote them as rational exponents, and now we can do what with them? We can add our exponents. What is 1/3 plus 1/2? 1/3 plus 1/2. Anybody?
1/6.
Nuh-uh.
5/6.
5/6. 5 over 6. You multiplied them.
Yeah.
Remember, you got to do 1/3 plus 1/2. You add your exponents when you're multiplying, and the bases are the same. So that is what they are when you combine them. So now that we've gotten the v's together, let's go back and rewrite them in variable or in radical form. The denominator is my new root. What is my denominator? So this is the 6th root of what? V to the 5th. Very good, Jalen. It's the 6th root of v to the 5th. Will 6 go into 5? So no v's get to escape. It stays trapped inside. Questions about that? Anybody? Okay, let's go down here to number 31. Are y'all all with me? I feel like I'm losing you a little bit. Guys, what is that numerator for? What's that raised to, technically? 4 to the what power? 1, right? What about the denominator? What will that be? 4 to the 1/3. 1/3, right? Because the root is my denominator, 3, and there is no exponent, so 4 to the 1st, 1/3. Now, what do we do with these two? Those bases are the same, right? But we're dividing, so what do we do with those exponents? We subtract. The base stays 4, stays the same. But what is 1 minus 1/3? It's 2/3. 1 minus 1/3 is 2/3. So this is 4 to the 2/3 power. Okay? So let's rewrite that as a radical. What is this as a radical? Cube root of 4 squared. Well, what is 4 squared? So this is the cube root of 16. Is 16 a perfect cube? No. Will a perfect cube go into 16? 8. 8 goes into 16 twice. So the cube root of 8 becomes a 2, and then we bring down the cube root of 2. So it's 2 times the cube root of 2. Hope y'all can see that. 2 times the cube root of 2 is the final answer for that one. Pretty tricky? Or y'all get it? All right, let me show you number 33, and then I'm going to go back up to the top. Number 33, let me show you what a lot of people do on this problem. They go ahead and they ask the question, how many times will 4 go into 10? And they start breaking it down like that. But I want you guys to catch something else. What do you notice about both 4 and 10? They're both even. They're both divisible by 2. So what I would encourage you when you see that, if you catch that, go ahead and rewrite it as a rational exponent. If I rewrote this as a rational exponent, what would it be? X to the, remember your root is your denominator, so it'd be 10/4, right? And once you've written it as a fractional exponent, remember, what can you do with that fractional exponent? Reduce it. What will 10 over 4 reduce to? 5 over 2. So in actual simplified form, y'all know what this is as a radical? It's the square root of x to the 5th. But then we can say, hey, will 2 go into 5? How many times? So x gets to come out twice, but it stays in how many times? Once. So it's x squared times the square root of x. You're going to have one of those tonight in your assignment. I know that for sure. Where it'll reduce like that, and I would encourage you to reduce it right off the bat. Okay? Now, I want you to go back up to the top with me, and I want to go first to number 26. No, let's do 25 first. What do y'all notice with 25? Yeah, the exponent is negative. And we don't deal with negative exponents. Okay? We don't deal with negative exponents. So we change negative exponents to positive exponents. There's only one way to change a negative exponent to positive exponent. And that is, you flip your fraction. But if you look at this problem, you're like, 100 is not a fraction. Can I make 100 a fraction? I can make anything a fraction by putting it over 1. So if I want to get rid of that negative 1/2 exponent, I flip my fraction. So I'm going to take 1 over 100, and I'm going to raise that to the positive 1/2. The positive 1/2. See? I flipped my fraction. That allowed me to get rid of my negative exponent. Now from here, isn't this just the square root of 1 over 100? Guys, is 1 a perfect square? What's the square root of 1? 1. Is 100 a perfect square? What's the square root of 100? So the square root of 1 over 100 is 1 over 10. Done. Okay, that one's done. Now, the reason I want to show you that one first is because all of a sudden, if I look at number 26, some people look at this right here, and they're like, oh, flip your fraction. And my response to that is, not yet. Okay? Don't flip your fraction yet. Because this is 16 to the 2/3 times 16 to the negative 1/3. What should you do first before you start thinking about flipping your fractions? Add your exponents, which in the process of adding your exponent is going to be 2 plus a negative. So technically you're going to be, well, 2/3 plus a negative. So it's going to be subtracting. But we combine these by adding those exponents. 2/3 plus negative 1/3. So 2/3 minus 1/3 is 1/3. Is it negative anymore? So don't worry about flipping your fractions unless you have to. And in this one, you don't. This is just going to be the cube root of 16. And of course, 16 is not a perfect cube, but we've already had this one before. 8 is, and it goes in there twice. So the cube root of 8 becomes a 2 times the cube root of 2. Okay? So I know I did that one real fast, but we've seen that before. So here's your homework assignment. Ready? From your worksheet that I gave you yesterday, you were already supposed to do numbers what? And hopefully you've done that. So that's part of your homework tonight. Finish that if you have not. The next part is numbers 11 through 21 odd. That's 6 additional problems. 11, 13, 15, 17, 19, and 21. That's your assignment for tonight. It's due tomorrow when you come to class, or if you're turning in online, it's due at the end of the school day tomorrow, okay? So work on that now. I'm going to stop this recording.